That's clutch of Zane.
Yeah, I thought.
Probably, but.
Why did you see it?
Oh.
Yeah, it's full.
You can divide 20 by 6. Especially this one.
I think you're gonna go with the
Now here, 2x against north, 1. Yeah, Devin divided that 2. I gotta. Okay. Shut up. This did that up here. 5x. Here you go. That's gotta be. I need to use that. So 79. You thought they were different. That should have been x minus 1. Did you just say 79? Yes.
Yeah.
Man,
I'm not.
I just did it so I could get it.
You good?
Oh, yeah, I got some of the first one. You got like minus 3. Yes, 4.
Brett, one of the shorts. Thank you. You've never seen a squirrel like that. I might have a pencil.
Alright, no better right now.
I haven't had I have like 4 kills too on that. I'm gonna hit a die.
What's the game plan for today?
What's the game?
Guys, action.
I think so. I've gone to
I
I think infield and avoid. That's terrible. It's a
big
hill.
Hey, alright, listen up here. Alright, it says, use GCF to factor the following polynomials. Well, first thing you have to do is identify the GCF. Evan, what do you think the GCF is for the first one? 4. That's it, because the other one doesn't have an X. So remember, this is where you put the 4 first and then parentheses, and you're basically dividing each piece by 4, and that gives you 3x squared plus 5. You're good as long as what's in parentheses doesn't have anything in common, and they don't. So sometimes you tend to overcomplicate these ones because you haven't done them in a while. All right, Zane, how about the second one? What do you think the GCF is for the second one?
5.
5 would be part of it, but it also has a variable.
Oh, 5 what?
To what power?
To the 3rd.
Yep, 5y to the 3rd. And then that gives me 3y minus what?
7.
Just 7. Sound like you're going to say something else. 3y minus 7. Because remember, you subtract exponents. 4 minus 3 is 1. 3 minus 3 is 0. Basically goes away. So you get 35 divided by 5, which is 7. So 5y cubed on the outside, 3y minus 7 would be on the inside. So that's all we need for number 2. And Amanda, how about number 3? What do you think the GCF is?
3C.
Good, 3c. Now for this, when I divide, I get 4c cubed plus 11c. Don't forget to put a minus 1 there. Okay, because 3c divided by 3c will be 1. Okay, for that. All right, so just kind of going back through some GCF stuff here. All right, just pay attention. Don't worry about writing this down. Factor the following. Really, the first part of what we're doing is nothing new. It's nothing new. Can anybody give me two numbers that multiply to get 9, add to get 6? Yep. 3 and 3. So this factors into x plus 3 times x plus 3. We know how to do this. The only difference is we get an answer where they're both the same. Okay, they're both the same. For number 2, you got to go to that little method we use. You got to multiply the first and the last together. So that's 100. What are two numbers that multiply to equal 100 and add to equal -20? All right, great.
-10.
-10 and -10. So I make this 4x squared minus 10x minus 10x plus 25. Take your GCF. GCF for the first two, Connor. What do you think?
2.
You're missing something. 2x. Oh, I didn't hear the x.
Yeah.
I'm sorry. 2x. So you get 2x minus 5 in parentheses. Hanan, what would you say the GCF is the second two? -5. Good, because you got to use the negative here. And now when I divide, -10x divided by -5 is positive 2x. 25 divided by -5 is -5. All right, not done. Zach, what's my final answer there?
2x, wait, parentheses, 2x minus 5, and then the other parentheses, 2x minus 5.
Okay, you get the same thing in both parentheses. This is not doing anything different. It's just that that final answer happens to be both the same. That's okay. So these are called perfect square trinomials. You don't need to memorize that. It's just sometimes they'll say factor the following perfect square trinomials. It's nothing different. That's the first part. Difference of squares we'll get to in a second. But, all right, this is on your guided notes. What is x squared minus 14x plus 49? There's no number in front of the x squared. So it multiplies to get 49, adds to get -7 or -14. Joe? And -7. It's just, yep, this is it. This is x minus 7 times x minus 7. Now, oftentimes you will see it written as x minus 7 quantity squared. I will take either answer, but sometimes like if you're on an ACT or you're on a multiple choice test, they might not give you the first answer. They might only list x minus 7 squared. So you got to be, you got to know that's the same thing. All right, 4x squared minus 12x plus 9. Great.
-6.
Well, how'd you get that? You're right, but you did something before.
4 times 9.
Yep, we multiply 4 times 9 to get 36. And we want to find two numbers that multiply to equal 36 and add to get -12. And so that's, and he said -6 and -6. So he's right. So we got 4x squared minus 6x minus 6x plus 9. And now, Sam, how about GCFs? What do you think? Yep.
Oh, okay, 2x for the first one,
And how about for the second one?
-3.
-3. And so when I do this, I get 2x. 4x squared divided by 2x is 2x. -6x divided by 2x is -3. -3 is my GCF here. That gives me 2x minus 3. And I get 2x minus 3, because that's my first one they share in common. Then I got a 2x minus 3 on the outside. Let's see. So that's going to give me 2x minus 3 squared for that. All right, you do that one. You do number 3.
Do like 9 times 4.
I don't know, 9 times 4 is 36.
Yeah, but then
6 times 6 is
how many
36.
factors go up? 12 times 3 is 36.
Yeah, but you could find 2 numbers on one side of 36 and 2 numbers that add to 12. 66.
I got 3x plus 2 feels like a 9.
Okay, good job.
Okay.
You said you need new shoes or just clean?
Yeah.
Just because your shoes are dirty doesn't mean you should get new.
Nah, bro.
Austin, did you get it?
Yeah, totally. Yeah, but.
All right, from what I see, most of you are on the right path. All right, 9 times 4 is 36. 2 numbers that multiply to equal 36. Add to get 12. 6 and 6. So now this becomes 9x squared plus 6x plus 6x plus 4. All right, you take the first 2. Go ahead. Go ahead. Just keep going. The first 2 will be a 3x. And then when I divide, it gives me 3x plus 2. And this one is going to be a 2. And I get the same thing. Okay, so you get 3x plus 2 times 3x plus 2. Now, when this happens, there's a little bit of a clue. And I want to, if you see this, it can make it the work a little bit easier. This still works. You can go through all this, but I want you to take a look. If you look at the first constant and the last constant, okay, if they are, now this one here would be a 1. If they are perfect squares, Perfect squares are numbers that have a square root. 4, 9, 16, 25, 36, 49. If they are perfect squares, then you think, all right, maybe I can try this ahead and then come back to grouping method. So a 9 and a 4 are perfect squares. Because we can come up with some harder ones that can be a little bit troublesome. So go ahead and write this one down. You got 4x squared minus 36x plus 81. Now, if we do our method, let's do our grouping method. Preston, what do I multiply together?
81 and 4.
81 and 4. Oh,
It's a big number.
I know. Okay, Connor.
Can I get the rest?
Yes. All right, 4 times 81, what is that, 324?
Yes.
Okay, now I need two numbers that multiply to get 324 and add to get what? Negative 36.
Got it.
Josh says he got it. What do you got?
I got 18 times 18, negative 18 times negative.
All right, now to save some time, we're going to go with what Josh said. He's correct. Negative 18 and negative 18. Problem is these can be harder because you got bigger numbers. So this is 4x squared minus 18x plus 81. That gives me a GCF of 2x. And how about that second set? Jordan?
9.
Okay. Negative 9. Good. So now when you divide, I get 2x. And then I get 2x minus 9. And then I get a negative 9 here. And I get 2x minus 9. So when I'm done, I get 2x minus 9 times 2x minus 9, which is 2x minus 9 squared. Now, if you are you're paying attention, what you can do is if you take a look, 4x squared is really 2x times 2x, right? And 81 is really negative 9 times negative 9. So if you recognize that the first and the last term are perfect squares, you can make your life just a little bit easier. So I want you to take a look at this one. So fill in 9x squared plus 60x plus 100. Now for this one, you would have to multiply 9 times what? 100. Don't do it yet. Don't do it. 9x squared and 100 are perfect squares. What squared gives you 9x squared? 3x. What squared gives you 100?
10.
10. So here's what I tell you to do. Before you go through all that, I would just say try 3x plus 10, since that's a plus, times 3x plus 10. See if it works before you go through the trouble of multiplying 9 times 100. Well, how do you see if it works? It kind of goes back to our guess and check. I know 3x times 3x is 9x squared. I know 10 times 10 is 100. You got to check the outer and the inner. Do they add up to 60? So then you're right. You can still do 9 times 100, which is 900. Okay? You can still do that. Oh, geez. All right. Fill in the missing piece. All right. Write this down. 16x squared minus 56x plus 49. Now here you have to multiply 16 times what? 49, what's that number?
784.
784. And you gotta find two numbers and multiply to 7084 and add negative 56. Before I do all that, I am going to check the first and the last term. Grant, are those perfect squares?
Yes.
Okay, what do you think I should try for my answer before I go through all that hard work?
4x and 7.
Okay, what should be my signs though? What do you think?
4x. 4x and minus 7.
They both got to be negative because the negative times the negative is a positive.
Come on, stop talking about that.
Okay, so I'm trying that first because you're multiplying 16 times 49. Now, you don't get a lot of these, but you get a couple of them so you can save a little bit of time. So I'm just going to test this out first and see if it's right. I know 4x times 4x is 16x squared. I got to check the middle. That's negative 28x. That's negative 28x. What's it add up to? So are we right? All right, make sure you get that down. That's your answer. 4x minus 7 times 4x minus 7, or
So listen to something else. I was like, negative 7.
or 4x minus 7 squared.
Add 7.
Okay. And I'll take either answer. I'll take either answer.
The color. I don't.
Hey, one thing I want you to make sure you understand. We're not doing anything different. You did this on the second part of the quiz. You take the first number times the last. We found two numbers, and then we did the GCF. That's the same. This will still work. I'm just trying to show you if you recognize that the first and the last term are perfect squares, then you can just try that first before you go to that extra steps. So 4 is 2 times 2. 81 is 9 times 9. The only thing you have to do is watch your signs. Especially if you get to these really big numbers, you're like, this looks so ridiculously hard. Well, there might be an easier way. All right, the last little thing there is what we call difference of squares. And let me just show you right here. And just pay attention. This isn't on your guided notes. If I FOIL this, x times x is x squared minus 4x plus 4x and negative 16. What's negative 4x plus 4x add up to? 0. So this just becomes x squared minus 16. The only time the middle term disappears is when one of them is plus and one of them is minus, and they're exactly the same. So if I multiply here, 3x times 3x is 9x squared plus 21x minus 21x minus 49. The two 21x's add up to 0. So you get 9x squared minus 49. Now here's our job. We're going to start here and go backwards. We're going to start here and go backwards. So this is called a difference of squares. And if you got two things that are being squared and you got a minus sign, you just figure out what squared gives you the first part and then the second part. So for this first one here, x squared minus 16. What do you think that's going to factor into? What are the two things that would have multiplied together to give me that? Okay, Christian?
X plus 4 and x times x minus 4.
Yep, this is all you got to do. X plus 4 times x minus 4. You can FOIL them to see if it works. But if you got two terms and there's no middle term, only if that's a minus sign. And then you get positive 4 and negative 4. That's it. But now you got to look at each one and say, all right, what square gives me the first term? What square gives me the last term? What about this one? I'll give you a hint. The first two terms are 3x and 3x. What should be the next part, Colin?
Plus 7 and minus 7.
But what about the y's?
Oh, plus 7y and minus 7y.
Good, you got to put a y with there. Plus 7y, minus 7y. It doesn't matter whether the plus or the minus comes first either. Okay, so you would just say plus 7y, minus 7y. Take a look at number 3. Oh, they throw a little bit bigger numbers at you. You guys can handle it though. 4x squared minus 25y to the 6th. It will be 2x and 2x. This one will be a plus, this one will be a minus, but how do I get 25y to the 6th? Grant, and then Joe, if you don't get it.
2x plus 5y cubed and 2x plus 5y cubed.
Good, it has to be, good.
Minus
Yep, it has to be y cubed. Because remember, when you multiply exponents, you actually add them. So make sure it's 2x plus 5y cubed, 2x minus 5y cubed. All right, how about number 4? Okay. How about number 4? Now you're pretty familiar with the smaller perfect squares. How do you tell if a bigger number is a perfect square? You take the square root of it. So, Grant?
Can I tell you the answer?
Yep.
11x cubed minus 8y squared.
Good.
And 11x cubed minus 8y squared.
One of them has to be a plus. As long as you have 1 minus 1 plus, you're okay. Square root of 121 is 11, so it'd be 11 times 11. Okay, 8 times 8 gives you 64, or negative 8 times 8 gives you negative 64. Okay, for that. I don't think this one's terribly hard. It just confuses some people. Let everybody write it down, Colin, or look at it. I think you already got it. Okay. Christiana? I would just use your calculator.
I don't know.
That would be, so. Square root of. I'm going.
4x minus 1 and 4x plus 1.
No, I knew. Yeah.
Think about it. Is your chair low?
Yeah.
So your legs are like really short, your chair is not low.
I'm gonna turn all the way down. Gonna make things easier.
I also look really down. I'm not sitting there.
Well, that would make your legs.
What do you got there, Colin, for number 5?
I mean, it touches stuff.
4x minus 1 and 4x plus 1.
Good. 4x minus 1, 4x plus 1. Sam,
I did something different.
what'd you get?
I did 8x minus 5 and then 2x plus 4.
8x minus 5 and then what?
2x plus 4.
Plus 4?
Yeah.
Well, here's what happens is to make sure you're right. If I'm right, when I FOIL these together, I gotta get back to the original problem. So now if you take a look what you're gonna get 16x squared, but what's 8x times 4? That is plus 32x, negative 5 times 2 is negative 10x, and negative 5 times 4 is negative 20. Remember, those are multiplying together. And so that's not gonna end up giving us the original. And really, if you have two terms and there's a minus sign, the only thing that's gonna work if they're exactly the same, one's a plus, one's a minus. So you shouldn't even have to try anything else. So 25x to the 8th minus 9y to the 5th. All right, this is a little bit of a trick question. Okay. It's a little bit of a trick question because, and is what I just said with Sam, I said it has to be exact same two things for this to work. Now I can write 5x to the 4th times 5x to the 4th, but you should see we're running into a problem. Anybody know what the problem is?
To the 5th power.
It's to the 5th power. And so you might say 3y squared, but this one can't be 3y squared and get to the 5th power. And these can't be different. They can't be different. So this doesn't work. This is not factorable. Okay, every now and then we come into something that's not factorable. Okay, because you can't write the exact same thing twice. The exact same thing. Okay, other than difference of squares, there's really nothing new. You got 1, 2, 3, 4, 5, 6, 7, 8 problems.
That's not too bad.
Now I forget what the directions say. You don't, but just factor each problem. I think it just says identify whether it's different. Don't worry about that. Just factor each problem. Write them down. Write the original problem down, and then factor each one.
Yeah, okay, actually.
Anyone was
So confusing.
Tomorrow. I'm gonna try.